changes are so fast that it's not simple to adapt. So fast that it's really you have to run and to really try to find a way to react and to adapt it, to be resilient to this kind of phenomena.
One of the most breathtaking mountain regions in the world. Famed for its snowscapes, the European Alps span more than 1,200 kilometres across 8 countries. But beneath this beauty, something is shifting. Over the past century, snowfall here has declined by more than a third. So what happens if the snow keeps disappearing?
We're driving through the beautiful Aosta Valley in northern Italy. We're heading to one of Europe's highest altitude research centres, and there scientists are interested in seeing how the mountains are being affected as climate change warms our world.
Okay, we're reaching the Salati Pass, close to 3,000 meters above sea level, on the border between Regione Valle d'Aosta and Regione Piemonte, two mountain regions here in Italy, northwest Italy. We are very close to the Monte Rosa massif. And up there we have a mountain research station, which is called Istituto Mosso. This is a sort of very nice playground for me.
Professor Freppaz is a nevologist, a snow expert. His playground is the mountains surrounding the Angelo Mosso Scientific Institute, one of Europe's highest altitude research stations. At over 3,000 metres, getting there requires a series of cable cars and a short hike, which at this altitude feels a lot longer.
So what are your main areas that you focus on here?
We study the snow, we study the soil, the plant physiology, the water quality. Here is very important also to check the quality, of the lakes, of the new lakes which form. You can study the snow, stay in your office in warm temperature in Torino, but it's not enough. You really need to come here to touch the snow, to smell the snow, to really understand what does it mean and what the behavior also in real conditions.
The Institute was opened in 1907 to study human physiology at high altitude, and now conducts research and long-term monitoring of snow and climate data. A small museum and gallery is also open to the public.
And that long history presumably means you've been able to really understand the changes that are happening here in the mountains.
It's really important to take care about the long time series of data is something that is very useful. You can understand trend, how the environment change. You can understand it on the basis of numbers or measurements that you can have. For example, this institute belongs to the Long-Term Ecological Research Network. It's an international network which really is a consortium of laboratories where we have long-time series of data.
And collecting that data involves working in extreme conditions. Today it is minus 10 degrees. Professor Freppaz and his colleagues from the University of Turin are racing to understand what's happening to the snow on the mountains, and that starts with digging a snow profile.
Michele, how far down are you having to dig this?
We try to reach the ground, if it's possible. We have more or less 1 meter 30 centimeters of snow.
Yeah.
Not too much, but enough, I mean.
It looks a lot.
Yeah, usually we may expect even more.
Yes, yeah.
But today we will dig more or less 1 meter.
Okay, wow.
Gabi, I think I need your help. So Gabi, it's your time.
Oh wow, goodness me. Look how far you've got down
you're
already.
Welcome.
Oh good. Let's get down there.
Try to reach the ground.
I'll give it a go.
How are you doing, Gabby?
It's hard work.
Yeah, that's why we study the human adaptation here. I mean,
Yeah.
you feel the elevation, no?
Yeah, definitely feeling it.
It's not simple. I mean, it's different to sea level or here.
Oh, I've reached something.
Can you see the ground?
Well, I
maybe?
think so. It's very frozen.
By carving into the snowpack, the hidden layers of winter can be revealed and properties of the snow can be analysed.
Oh, that was hard. Hard work, but good.
The first thing that I will measure is the temperature. So it's very useful and it's very important to know the temperatures inside the snowpack. So from 140 centimeters, we expect a temperature below zero. It's quite cold today. And the temperature is minus 4.5. And now I try to measure just at the bottom, close to the soil surface, to see if this snow is enough to insulate the soil for very low temperatures. 0.2.
Oh, wow.
The soil is warm, warm enough.
Yeah,
So we don't have any freezing.
yeah,
So the soil is really well protected
Yeah.
from the temperature.
yeah.
Even at this elevation, in the Alpine tundra, if we have, at least 1 meter of snow, not too much dense, the snow acts as a perfect insulator.
Covered in snow for most of the year, the Alpine tundra is a unique and fragile ecosystem. Above the tree line, it's made up of mosses, grasses, small shrubs, and 70 species of wildflower. Snow plays a crucial and unexpected role in protecting mountain soils and its microbial life during winter.
So what happens when there isn't enough snow? Does it affect the soil below?
If we have a lack of snow, maybe some winter where we also have delay in snowpack accumulation, we may observe soil freezing. And in that case, we can expect, some damage, some effect on the soil, nutrient cycling, on the soil microbial activities. So it's something that we have to keep in mind.
So the soil is being protected by the snow?
Absolutely.
So are changes occurring in alpine ecosystems because there isn't as much snow?
Yeah, this elevation, usually we still expect, snow. In the northwest Italian Alps, for example, there is an elevation, it's 1,500 meters. Below this elevation, in recent years, we have a lack of snow. So these ecosystems are more affected than usual by soil freezing at that elevation, because instead of snow, sometimes we have rain, or maybe we have snow and melt very fast. So at that elevation, the ecosystems are suffering by that.
The snow profile they cut reveals different layers of snow over the last 3 months, each layer telling a different story.
Relatively fresh snow,
Okay.
so with different properties. I expect also different grain shapes and different grain size. And here, of course, if we go deeper, I have older snow, which has been accumulated in early winter, late autumn. And so in each different layers, I will try to recognize the different snow crystals. It's very important. And of course, I'm searching also for weak layer, so layer which can be, which can contribute to the release of snow avalanches. Concerning the snow avalanche forecasting, it's very important to try to detect the weak layers inside the snowpack.
So have you found a weak layer there?
Just at the bottom.
At the bottom, okay.
Very soft, and now maybe I can just focus my attention there. I would like to start because I think that just at the bottom there are some very nice crystals.
The crystals have grown due to a strong temperature gradient between the soil and the colder surface, creating a dangerously weak layer known as depth hoar. It's the large, angular shape of the crystals that can really impact the stability of the snowpack.
During the early winter, we didn't have enough snow, so we have some metamorphism, some transformation of grains, which create these faceted or depth of crystals.
Yes.
Which are sort of single grains. They are not bonded to each other, and then create usually this very weak layer just at the bottom.
So it's when they're bonded together, that's when they become stronger. Oh, wow. Yes, they're very jagged.
On cold, clear nights when water vapour deposits on the snow surface, a similar layer of ice crystals known as surface hoar can develop, creating further weak layers under fresh snowfall. This season in Europe has seen an unusually persistent high avalanche danger and above average deaths. The week after filming, 3 people died in an avalanche in a neighbouring valley. Avalanches are a natural phenomenon. The snowpack is the total build-up of layered snow that accumulates on the ground each winter. Every time it snows, or there's a change in temperature, it transforms the snowpack layers. Intense warming during the day, or heavy rainfall, can contribute to snowpack instability. When unstable layers of snow are covered with fresh snow, it increases the risk of avalanche. Because the weaker layer below is less cohesive, a slab avalanche is released. Some avalanches move slowly, but still carry enormous force. In a warming climate, the danger isn't just more avalanches, but also a change in the type of avalanches. This snowboarder was almost caught out when they accidentally triggered a snow slab avalanche. The Institute's work provides vital evidence of how warming temperatures are altering snowfall patterns, snow depth, and the stability of the snowpack. Changes with profound implications for mountain safety and the ski industry alike. Arnaldo Welf has been a mountain guide here for over 30 years. Now he manages the ski area in Gressone La Trinité. His main job is to prevent avalanches reaching the ski runs.
È cambiato abbastanza perché sono diminuite le precipitazioni, però sono magari aumentate in quantità, cioè magari poca neve in tanto tempo. Magari in un mese nevica 3 volte, se va bene che nevica. E allora uno pensa che quando hai mezzo metro di neve non è pericoloso, invece alle volte è più pericoloso, come quest'anno, avere mezzo metro di neve che non 1 metro tutto assieme. E diciamo che è cambiato un po' in questa maniera e soprattutto si è spostata la stagione, in primavera nevica tanto e a dicembre nevica meno, alle volte non nevica neanche nei mesi di dicembre.
Arnaldo is on high alert after any new large snowfalls and having to adapt how they manage the slopes. Like many other mountain managers, they are triggering artificial avalanches before skiers hit the slopes.
Se riesci a volare il giorno dopo, prenoti l'elicottero, cioè chiami il pilota, gli dici alle 8, alle 7, se riesci vieni a prendermi, e da lì devi calcolare, devi andare in giro e pulire le grandi valanghe che scendono sul comprensorio, se non sono già scese di notte. Quindi fai un giro e proprio dall'elicottero devi capire abbastanza velocemente dove andare a cercare il posto dove staccare la valanga, che subito non ti viene spontaneo, poi dopo anni di prove riesci abbastanza velocemente a capire dove andare.
The changes in snow composition are also making it harder to remove dangerous snow build-up.
È più difficile lavorare con l'esplosivo sulle nevi umide, quando devi staccare le valanghe. Ci sono certi momenti che non riesci proprio a staccarle, perché sono troppo pesanti e l'esplosivo praticamente aumenta il carico della neve e la fa scivolare. E invece nella neve umida non riesce a spostare la neve e non le fa cadere le valanghe. Quindi sei obbligato a chiudere la pista, non puoi far altro.
Arnaldo and other mountain guides are essential to scientists working in the mountains, ensuring safe conditions and to help manage sensors and instruments. Their data is fed into a daily avalanche bulletin for the Aosta Valley, meaning the mountain teams can judge the avalanche risk.
So why are avalanches changing?
If you have a wetter snow, You expect wet avalanches even during winter time, and this kind of avalanches, it's more complicated to manage it, especially, for example, using the artificial snow avalanche triggering. No, it's something new, but you are facing new conditions. So you really need to adapt to find new solutions. So it's something which is changing very fast.
As the climate warms, the mountains are beginning to feel the strain, and that is impacting the local economy that depends on snow. We're heading up the mountain again, day 2 of us filming with the scientists at the Angelo Mosso Institute here in Italy. But it's not just the precious ecosystems that the snow cover is really important for. Actually, for the ski industry here in the Alps, it's causing huge problems, the lack of snow, every year. In fact, across Europe, many resorts have had to shut. As snowfall declines, many low-altitude ski resorts have shut their doors. Watching this film and the snow we've been in, you wouldn't believe it, but since 1920, parts of the European Alps, particularly in the southwest, have lost nearly half their seasonal snow. For Italy's ski industry, survival now depends on adaptation. Today, around 90% of pistes rely on artificial snow. Giorgio Munari runs Monte Rosa Ski, where every run is equipped with modern snowmaking systems that keep the slopes open throughout winter.
How does the artificial snow system work here?
L'innevamento artificiale è composto normalmente da 2 fattori. Uno l'acqua e l'altro l'aria. Si mettono all'interno dei cannoni, che possono essere a bassa pressione o ad alta pressione, queste 2 miscele, e in questo modo, sparando a 20 atmosfere, si creano dei cristalli che si depositano e si trasformano in neve. L'importante al giorno d'oggi è avere la potenza elettrica per poterlo fare e soprattutto dietro una riserva di acqua significativa. Per questo che abbiamo costruito dei laghi che ci consentono poi l'utilizzo in breve termine dell'acqua che durante la primavera accumuliamo. È più o meno la stessa acqua che noi buttiamo sulle piste, noi la accumuliamo poi in primavera per utilizzarla al mese di novembre.
So there's no chemicals at all in the artificial snow?
No, non c'è niente di chimico. E poi tieni conto che quando noi l'accumuliamo è il momento del grosso scioglimento delle nevi. Quindi andiamo a togliere l'acqua, chiamiamola la natura, ma quando ce n'è già in abbondanza. E poi verrà restituita in primavera al disgelo.
Technology is giving them a helping hand to make the most of the snow they have and to keep it green. The snowcats are fitted with state-of-the-art LiDAR, which detects how much snow is on the slopes, allowing them to target the areas needing more snow specifically with the artificial snow system, rather than randomly, which would use up more energy.
Why is it so important you minimise the impact on the environment here?
Innanzitutto perché noi viviamo qua. E quindi se la nostra qualità dell'aria e della vita è migliore, ne avvantaggiamo tutti noi che viviamo qua.
Lots of resorts are having to close across Europe. Why is it so important that we keep having snow here?
Il cambiamento climatico sicuramente una grossa influenza sulle stazioni che sono più basse ce l'ha, anche perché al di là di non avere grosse temperature marginali per poter innevare, spesso si trovi che piove invece di nevicare e questo qui è un problema. Le stazioni a bassa quota, a mio avviso, dei problemi in futuro ce l'avranno. Se gli alberghi sono pieni, se i ristoranti lavorano, c'è lavoro per tutti e quindi le persone possono vivere in montagna e stare bene in montagna, perché se non hai lavoro e se non guadagni poi la montagna spariscono tutti e diventa disabitata.
But the consequences of reduced snowfall go far beyond snow tourism.
We can see the beautiful places, the moraine, the U-valley shaped by the glacier 100 years ago.
Oh yes, I can see some of it just peeking through the clouds there, the blue ice, yeah.
The scientists at the Angelo Mosso Scientific Institute are concerned about what it's doing to the country's glaciers.
This glacier is one of the most beautiful Italian glaciers. In Italy we have around 1,000 glaciers. Most of them are smaller, very small, less than half kilometer. And now we are keep going the monitoring of all Italian glaciers by remote sensing.
Glaciers are among the most visible indicators of climate change. On Monte Rosa, the team have been studying the Indren and Lys glaciers. They've retreated by more than a kilometre over the past century.
Why is it so important we monitor these glaciers?
Monitoring glaciers is very important because they are climate drivers. They have very huge latency to respond to the climate change, and so we can have information on the layers of glaciers. For example, now every year all the snow melt and a little bit ice melt every year, and now we can see on the water coming down from the rivers the ice of the 80s. Every year we are monitoring around 200 glaciers by come to the glacier to take a photo and measure directly of the retreat of the tongues. The last part of the glacier, so I mean around 700 glaciers, we are monitoring them by remote sensing technique.
So you've really had a front row seat to the impact that climate change is having on glaciers like this, haven't you? What sort of risks are we talking about?
Yes, the risk of the retreat is the new part of the bedrock are free of ice, and so the tensions, the pressure from the glaciers are released by the bedrock, and so the risk are rock falls, avalanches that happens just after the glacier retreat the upper part of the mountains.
And as we saw in our previous film, in extreme cases, the whole glacier can become unstable.
Hazard detection then is quite an important part of your job.
Yes, hazard mitigation is one of the part of the researches that we are coming, and Italian Glaciological Committee is a committee that the priority is to monitoring glaciers, but after the monitoring, the risk and hazard connected by the human activities. So this is a very important part for the future.
Glaciers act as natural reservoirs, storing winter snowfall and releasing it slowly in spring and summer. As they shrink, river water increases, giving the illusion of plentiful supplies. But once a glacier retreats past a certain threshold, meltwater declines sharply. It means millions of cubic metres of ice, and with it, precious freshwater storage, is disappearing, threatening not just water supply, but also the clean energy generated from it. And it's not just the glaciers that hold a huge amount of water.
This is a meteorological station, a NIVO meteorological station.
The array of scientific equipment and sensors outside the Institute are constantly monitoring conditions in the mountains. Now, using a new cosmic ray neutron sensor, they can measure the water content within the snowpack in real time.
We count the amount of neutrons which are produced by cosmic rays which interact with the atmosphere. When cosmic rays with high energy particles interact with the atmosphere with nitrogen and oxygen, create neutrons, and these neutrons interact with the water molecules inside the snow.
As Professor Freppaz explains, cosmic rays are tiny high-energy particles that come from space. When they hit the atmosphere, they interact with oxygen and nitrogen to create neutrons. Snow contains water, or H2O, and the hydrogen atoms slow down and absorb neutrons. So the more water there is in the snow, the fewer neutrons reach a sensor on the ground. A second sensor is placed above the snowpack, allowing scientists to work out how much the neutron signal is reduced by the snow, and to estimate how much water the snow holds. This breakthrough is transforming how they track melt patterns and predict water shortages for the mountain communities that depend on it.
The Alps are considered the water tower of Europe. They're so vital for water supply. So what does it mean if there is less snow?
It's so important to monitor because all this water which is stored in the snow is released, into the soil, to the environment during spring snow melting. At this elevation in the Alps, the amount of water which can be stored is close to 1,400 millimeters. It means 1,400 liters per square meter, a huge amount of water. But in 3-4 weeks, sometimes even more, is released into the soil to plants, and is released when also humans need more, because during springtime you have the agriculture, plants start growing again, and so it's a strategic reservoir of water.
These issues aren't unique to the Alps. Global warming is affecting mountain ranges across the world, from the Himalayas to the Andes. The museum here is dedicated to the various research going on, focusing on the collaboration which is needed to tackle one of the planet's biggest problems.
We have a lot of friends which came, and we try to combine all the different subjects together. It's the only way to have a multidisciplinary, interdisciplinary approach to really understand. What is really important also that here we try, to also people from abroad. I think that science is a good example of a community. Doesn't matter if you come from Russia, from other countries, we really try to work together. And also at that time, Angelo Mosso have money to build this institute thanks to international cooperation.
Future snowfall and the systems that depend on it are at the mercy of climate action. A strong cut in global emissions is needed to slow down the rate of warming and the impact on snow cover. If we continue without change, these beautiful mountain regions, which are heating up twice as fast than the lands below them, could be significantly different in the future.
So you must feel quite strongly then about future-proofing these areas for the next generation.
Yeah, I think we need a new generation. Maybe that's why also we invest a lot of energy and passion in training, teaching. I'm a professor at university, so I'm a researcher, but I'm also a professor. That's my main mission. So we really need to prepare a new generation of technicians, of scientists, able maybe to overcome the mistake that we did, and maybe find a new solution, and maybe take care about the environment maybe better than my generation do.
Do you feel hopeful about the future?
I'm optimistic, I'm hopeful, I have to be. I have also 2 kids, my family, so I really have to be. I live in the mountain. I'm from this very little village here in the valley. So for me, I grew up with snow, studying snow. I think I have another option for me. It's the only job I could do, to work in mountain, to study mountain, soil, snow. How to say, I'm in a certain sense some sadness. I think that we have to study it to find the best solution in order to really keep the winter cool, keep the snow in mountain. It's the only way for me just to do this challenge.